Semiconductor laser. This laser uses semiconductor as the gain medium or active medium, and semiconductor laser is a two-level laser um, in which the pumping method that is called direct conversion is used, and semiconductor laser is also known as gallium arsenide laser, as gallium arsenide is the most oftenly used gain medium. And construction, and this is the this figure shows this is PN junction, P junction and N junction. P is the hole conductivity, and N is the electron conductivity, and this thick layer which I have drawn here is metal contacts, and this P layer is known as the upper electrode, and this part is junction. Junction is at where the positive the hole and the electron are injected, and the P side and N side is connected with a forward biased voltage. The single crystal of gallium arsenide, we can use other gain medium. The single crystal of gallium arsenide used as a gain medium, which is 0.5 micrometer thickness, and it consists of two parts of P type and N type. The photon emission is stimulated in a thin layer of PN junction. It means at a thin upper layer of PN junction involves the emission of photon when we apply forward biased voltage, and the electrical voltage is applied to the crystal through upper electrode. So and the N junction is grounded, and the metal contacts of P side is given forward voltage. The N faces of the junction diode is well polished and parallel to each other, acts as optical resonator, means there are mirrors at where photons and electrons are reflected back, and by this process, because one side mirror is fully silver and another side is partially silver, and from partially silver phase we get the output laser beam. But because fully reflected mirrors can reflect beam completely. And the gain medium, we can use gallium arsenide, aluminum gallium arsenide, and indium gallium phosphorus, gallium what is that, gallium GAN, indium gallium arsenide, indium gallium arsenide nitrogen. But gallium arsenide is the most commonly used in between all these gain medium. And let's see the working. This is conduction band, this is valence band. These are the free electrons, these are free holes. There is laser light, and this is the band gap, because the difference between conduction band and valence band represents band gap, and this is the laser light coming out. And electron, this is and this is the energy, electron energy, and this is energy barrier. So when PN junction is forward biased, the forward biased by applying some electrical voltage, the electron holes are injected into the junction region. So electron and holes started to gathering there. This creates a large amount of electrons in conduction band and holes in valence band, as shown in figure, because here we have already applied the voltage. And if the population density is high, the population inversion can be achieved. The electron holes recombine with each other at the junction to produce radiation in the form of light. The photon beam is reflected back by reflecting mirror and stimulate the other recombination process. So basically, this is the continuous process. At where the beam is reflected back again and again by a fully silver mirror, and the stimulated recombination of excited electron and holes give rise to laser beam. The increase of forward biased voltage causes emission more and more, because it means emission of more photon improves the increase in forward biased voltage, or improves the forward biased voltage inside the semiconductor laser, and light production becomes stronger. It gives out laser beam of infrared radiation of wavelength of range between 8300 Armstrong to 8500 Armstrong. And the application of fiber optics communication. The application of semiconductor laser is fiber optics communication, and to heal the wounds by IR infrared radiation, used as painkillers, used as CD, DVDs, write CD, laser printers, barcode reader,